Hello, I'm PT Choi, the nerve acupressure method. Let's learn about the Thixotropy phenomenon, which is one of the characteristics of fascia. The Thixotropy phenomenon is said in the chemical dictionary when external force is applied to high-concentration colloidal or polymer solutions, fluidity is shown, and when external force is removed, fluidity is lost. And in the life science dictionary, it says, the property of colloidal gel being reversibly solvated by mechanical forces such as shaking and compression. Some of the typical ones are ketchup and mayonnaise. And Rolfing therapy says that thixotropism also occurs in the fascia. In other words, the sticky gel state changes smoothly to a sol state. What is changed is not the same, but when this external force is removed, the dose state changes back to the gel state. However, some recover 100% and others do not. That is, it is not completely gelate and remains a little sol state. There are cases. In other words, if we continuously apply a certain stimulus to our body, it does not return to its original state, but it can remain somewhat soft. This is how we can see it. This is a thixotropy phenomenon, and it's also seen in the fascia. It's the application of these properties to therapy. That is one basis for changes in our body when external forces, such as vibration, massage, stretching, etc., are applied. I'm going to experiment with ketchup. If you squeeze the ketchup as it is, the state is a sticky gel, so you can see that it stays the same. In other words, it's stuck against gravity. Because it has a high viscosity, it is attached like this. Let's see what happens when you apply an external force here. I'll apply the external force by vibration. Here, let's apply external force with very high vibration. If you apply external force with high vibration, you can see that the sticky gel state changes to a sol state and gradually flows down. It goes down little by little, right? Because the sticky state changes to a watery state. The viscosity weakens and flows down. Let's try to remove the external force. When the external force is removed, the property of returning to its original state, that is, the state of sol water, changes back to the gel state and stays in place. This property is called the thixotropy phenomenon. Okay, it stays in place. I'll apply the external force one more time. If you apply external force in this state, you can see that the gel state changes back to the sol state and flows down again. Let's stop the external force again. When the external force is removed, the dose state changes back to the gel state, and it can be seen that it stays still without moving. We believe that this phenomenon is also present in our fascia, and when we stimulate the fascia, we can see the effect of softening the fascia and removing the adhesion. Let's apply the external force again. This phenomenon can also be applied to fascia relaxation. Whether it's vibrating, stretching, acupressure, massage, when these stimuli are applied properly, you can see the effect of softening the fascia. That is, softening the body. This phenomenon will be the biggest feature of the thixotropy phenomenon. When the external force is removed, it returns to its original state and stays in place again. Lastly, let's apply the external force one more time.